My name is Tarek. Today our focus is on sockets. What are sockets? How we can understand sockets, and also we will write some code to implement the server socket. So let's start the lecture. This term socket has came from an electricity and phone socket metaphor, where sockets act as an interface that plug into each other over the network. So it's basically something a device. You have a device, and you need the power to switch on the device. So you plug your socket into the power station. So it's kind of an example here. We have a electricity network, and we plug the fan socket on the electricity on the power socket, right? So in the same way, in older days we used to have the telephone sockets also. So what the main purpose of the socket is to join to to you can say to devices, or to join to different processes, so that communication can happen between them. This is a very popular example, Dixie Cups. One popular example of sockets are Dixie Cups game, played where we took two papers and tied them together with the help of a string to form a telephone. So one person speaks from one cup, and the another one, he can hear that while having the cup on his ears, right? Dixie cups in this example represent sockets, so it's an easy example to understand the sockets. The stream is flowing sequence of characters that flow into or out of process, right? So the voice that is traveled from one point to another, so that think we can think of them as a stream, as a flow of sequence, right? Message destinations are specified as socket addresses. Each socket address is combination of IP address and a port. So these both things, we need these both things to establish a socket. Or the port number is an integer that is needed to distinguish between services running on the same machine. Now this is the main point. A socket programming construct can use either UDP or TCP protocols, UDP or TCP transport protocols. Sockets that use UDP for transport of packets are called datagram sockets, and sockets that use TCP for transport are called stream sockets. So we will discuss about UDP and TCP. So when we use UDP, that is called those packets are called datagram packets, and when we use TCP, those streams or those data packets are called the stream sockets. Why we call them stream sockets, we will discuss later. So which transport protocol? TCP, which is transmission control protocol, UDP, user datagram protocol, and we right now we are discussing only these two. So which one should I use? TCP is a reliable protocol. UDP is not. TCP is connection oriented. UDP is connectionless. TCP incurs overhead. UDP incurs few overhead. These overhead are actually the headers that are attached while transferring the packet from one point to another point. We will discuss the details later. UDP has a size limit of 64K. In TCP, there is no size. Okay, so TCP is a connection based. We need a connection. We need a stable connection. So both the points of both the devices are connected. They are constantly connected to communicate with each other. Using data streams to communicate secured, low possibility to lose data. So in UDP, what we don't have any connection. There is no connection. Using data packets, which is datagram, to communicate. So we do not need any stable connection. We can so there is no connection, and UDP packets can be sent without having a stable connection. Not secure, possible to lose data. Now let's talk about UDP in detail. UDP is simple and efficient, but not reliable. Definitely, it's not reliable because we do not have a stable connection. User datagram protocol transports packets in a connectionless manner. In a connectionless communication, each data packet, also called datagram, is addressed and routed individually and may arrive at the receiver in any order. So when we discuss the details of the UDP, we will see that the packets are sent. There are multiple packets sent. So it's also possible that the sequence of sending of data can be rearranged when it arrived at the receiver's end. Okay, now let's create let's write UDP server. Today we will write the server. We'll write the program actually that will serve as a UDP server. So what is a server? For server, we need to create the datagram socket object and bind it to a specific local port. So we have a class in Java, datagram socket, and we will bind it to the port. Binding means attaching a port number to that socket. Create a byte array for receiving the data. You'll create a byte array, create datagram packet object specifying the data array, invoke the receive method of the socket with reference to the datagram object. Let's implement this UDP server. Okay, so we will extend the code we did in the last session, and here we will create a new class, and we will call this UDP server. So for simplicity's sake, I will write my code in the main class, in the main method actually. I won't be implementing any object-oriented principles here, since my focus is on the implementation of the server rather than implementing the object-oriented rules, right? So let's implement the main method. So in this main method, let's say first let me write UDP server. Okay. Now I will declare the datagram socket. I will declare the datagram socket here. This is the datagram socket. Okay. I'll say a server socket equals to, let's initialize this with null, and let's say I am going to specify a port, and the port number is 5556. This is my port number, and let me initialize the server socket now. Server socket is equals to new datagram socket, and I'll pass the port number here. Okay, I have a method which accepts the port number, and I have passed the port number. Okay, now let's simply print that the server socket has started. I will say UDP server, and so I will say datagram socket on port, datagram socket started. Okay, on port, you can say port is this one, right? Okay, now to receive data, since it's the server socket, we need to receive data. So to receive data, we need to initialize datagram packet. So let's initialize datagram packet, okay, and we'll say receive data, new datagram packet. So to receive the data, we have different methods here. Okay, so I will implement this method, in which we have a byte array and the length of the data. Okay, so to do this, to pass these two values, let me initialize length. Data length is equal to, let's say, 100, and I need to initialize the byte array also. Okay, this is actually a buffer which will contain the data. So I'll say received bytes, received data, and I'm initialized with that data length, right? And I'll then pass these two things here, received data and data length. Okay. Okay, okay, so it's saying that socket exception can be thrown. So what I can do is say throws socket exception. The parent of the socket exception is IO exception. Okay, so let me implement the IO exception. Exception. Okay, now that's fine. Okay, now what's next? The next is this server should listen. The servers, the responsibility of the servers are to listen to the clients. So we need to write a method which is responsible for listening. So for that, I'll first write infinite loop. So what I'm doing here actually, it will listen to the request and then it will not, the program, the server will not terminate. The program will go again and it will again start to listen. So now I will say server socket dot receive, and here it needs is the it needs datagram packet. So I have packet here. So this received data is actually datagram packet object. So now at this point, when the program will run and it will reach on this line, line number 35, which is this one, the server will start listening. It means it will hold there and it will start listening and it will wait for the packet to arrive. As the packet will arrive, it will receive the packet and do the processing, right? So let me write here sysout, and I will say UDP server, and I will say server is listening. Now we have the data packet. Now the data packet has arrived. Now what next? The next is to extract the data from the data packet. So we have received data, the datagram packet, received data dot, we can get address. So it's the address from where is this source address, or you can say it's the client address. When client will send its data packet, there are other information which are bundled in that packet, and those information is the client IP and the client port, right? We can extract these information. So we will get address, and it will receive that it in inet address. You can say client IP, or you can say source IP. Okay. Now, next thing is what we will receive. We will receive get port, right? So it's the integer value. We will contain that in integer client port. Okay, and now the actual message. Let's contain that actual message in a string variable, new string, and I will say receive data dot get data. So get data is actually the actual message that has been sent, that will be sent. Okay, now what we can say, we can print here, right? We can simply print. We can say some dot out. We can say client IP address is what is client IP, right? And then we can also say client port is port, right? Then we can see that client message is message, right? So this is it. As you can see, it's not very hard, not very complicated. It's very straightforward. So let's quickly recap. What we initially did, we created a object of server socket using the Datagram socket. We supplied the port, and then we created a data packet. Since we need to receive the data packet sent from the client, so we created an object of data packet, and it's and we with the initial parameters, the byte array, we initialize that with byte array and the initial length. And then the receive method. The receive method is actually the method which will listen. As the packet will come here, will arrive here. So we will extract data from that packet, which is the client's IP, client port, and here it's client port, client, and the actual message. And then we are simply printing it. Nothing very complicated. Now in the next lecture, we will implement the UDP client. Thank you for watching.